Next example, we're looking at the conservation of momentum in an isolated system consisting of an astronaut and a wrench. So we gotta remember that space is kind of frictionless, and that the astronaut is floating in space for 100 meters from her ship, but her safety cable becomes unlatched. She and the ship are motionless relative to each other. Right? So we're saying the mass is about 100 kilograms for her, and she has a 1.0 wrench and only a 20-minute air supply. Now we have to basically get back to ship by throwing the wrench away from her. In what direction should she throw the wrench? What is the magnitude of her recoil velocity if she throws the wrench at 10 meters per second? Okay, so that's the first question. We'll get to the second question afterwards. But let's figure out the first question, right? So here we go. We have 100. With the write out the equation first. 100 V is going to be equal to 1 times 10. 100 being the kilograms. V is a recoil velocity. And she's trying to throw in the opposite direction, right? And we can figure out V by saying that it's 100 or 110 over 100, I'm sorry. I'm trying to isolate it, just trying to solve it better, right? And we can eventually say that V is about 0.1 meters per second, right? Now keep that in mind. Then we're going to have to look at time is taken by this velocity to reach your ship, is going to be T, which is equal to S over V, which will be equal to 100 over 0.1. Now, when we do this calculation, it's going to be 1,000 seconds, right? And the T, right, is going to be 1,000 seconds is going to be 16 minutes and 40 seconds, which is enough, right? So we're going to find out that she has enough oxygen for it, right? After we apply it back to the fact that she only has 20 minutes left of air. If you subtract that by 1,000, you'll see that she has 16 minutes and 40 seconds left. Okay. After we figure it out, she only has 16 minutes of air supply. Their velocity has to be, her velocity, right? To figure that out again, we put S over T. Is going to be 100 over this times 60. And velocity is going to be ended up with 0.1042 meters per second. Now that's important, right? Because she has to throw the wrench at the velocity of this number times 100. So we do that again. It's going to be equal to basically, let me rewrite this. 100 times 0.1042. So we're going to have the x and the u and this, right? And after we do algebra, we're going to be left with 10.42, and then u is going to be 10.42 meters. Right? So that's the first question. And yes, it will be great enough for her to have a recoil back to the ship after we solve for this number. So it's 10.42, I'm sorry for the units, meters per second. Thank you.